Okay, for today, it's so much easier than we've been doing for the last few days. It's kind of nice. You get the chance to just kind of practice a little bit of putting these sequences into calculators. And the main difference, the only difference for today is we use some different terminology for things. I think you know that if I add something each time, that's growth. You get that, right? Pay attention. If I add something each time, it's growth. Or if I multiply by something, is it always growth? No. If I multiply by something bigger than what? 1. So if it's like multiplied by 1.2, everybody gets that that's going to make it grow. But here's some complicated ones. What if I'm multiplying by 4? Well, I know it's growing, but what's its growth rate? Most common mistake answer, 400%. Wrong. 4 times as big? That's not a growth rate. All right, so let me help you understand how you figure out the growth rate. I know you know that if I said 1.4, you would be able to, in your head, go, oh, so that's 40% growth. At least I think you would be able to do that, wouldn't you? That's 40% growth. And they're also a little tricky when I multiply by something like 0.8, because guess what people think the growth rate is? Well, they think it's 80% growth. That isn't even growing. What's multiplying by 0.8 doing? Decaying or decreasing. And the decay rate is not 80%. It's actually, it's kind of like if you were at a store, there's how much you pay and there's how much you save. If it's 20% off, then it's 80% on, right? Know what I mean? Okay, so then if you're timesing by 0.8, then that's really, here's the way I like to think of it, the same as timesing by 1 minus 0.2. Why would you ever write that? Because it tells you the decay rate by writing as a 1 plus or a minus something. Do you get 1 minus 0.2 is the same thing as 0.8? It's just better because I can see that it's decaying by 20%. That's 20% decay. All right. That's the hard part of this. So a lot of these slides are super simple. Like, what's this growth? This is decay. Decay generally is going down. Now, generally, I would say I like to see decay looking more like that. But, it's okay. They got these pictures off the internet somewhere probably. All right. What does U sub 1 represent? That's the first term. But you know what? It's actually a bad question. Because do you get U sub 1? It doesn't have to be the first term. It could be the first term. U sub 0. We never use U sub negative numbers, but the lowest one you could possibly use would be U sub 0. But when you're writing an equation, you get to pick that. If I go like this, and then I just decided that my smallest one would be U sub 1. Could I have chosen my smallest one to be U sub 0? Yeah, I could have. So U sub 1 isn't always the first term. It sometimes is. All right. What does U sub n represent? Remember me saying that from the beginning? It was a term. Which term was it? Any term. That's any random term. And then what does that represent? If this is any random term, what's that one? Not the first term. The one right in front of it. Yes. If this is any random term, this was the one right in front of it. So like if I have a list and I get to 34 and then 36 and then 38, ... and I say, which term is that? I don't know. U sub n. Because I don't know how it started. Could be the 12th term. It could be like the 3rd term. I don't know. But then this would have to be U sub n minus 1. So when we're reading these formulas, it's saying any term is given by the term in front of it, and then you do something. How do you do these again? You take this and you do something to them. Well, you either subtract them to get a common what? Difference, or you divide them to get a common ratio. Okay, good. So this is a big review of like everything we've learned so far. Does this look like growth or decay? Growth, not too tough. Does this look like growth or decay? Decay. Now, the devil's in the details. That was not 400% growth. I just mentioned it a second ago. Do you remember me saying it was smart to write it as 1 plus or minus something? 4 is the same as 1 plus 3. Who wants to guess what the growth rate is now that I've written it that way? Yes? 300%. You see how writing a 4 as a 1 plus 3 helps me to see 1 just brings back the original amount. You times by 1, nothing changed. It's what's above 1 that's making it grow. So that's 30, it's not 30% growth, sorry, that's 300% growth. How do I know it's 300 versus 30? You always move the decimal 2 spots. And this 3 has a decimal at the end. Move 2 spots, 300% growth. All right, so what if I'm in the middle of a problem and it's timesing by 7? You're going to be tempted to say 700% growth. You're wrong. What is it? 600% growth, because it's like 1 plus 6. The 1 plus or the 1 minus really does help. How about if it's a 0.7 in the middle of the problem? Do you get why kids often say it's 70% growth? It's not. What should I write it as again? A 1 plus or a 1 minus 0.3 in this case. Why is that so much smarter? Because now I can say, oh, it's 30% decay, or decreasing by 30%. So if you can just get yourself to take these numbers and write them as 1 plus or 1 minus something, it's easy. Okay? Here's another common one. They see a number that's usually associated with like a normal decay rate, and they get tempted to go, oh, I know it's decay, 25% decay. True or false? False. Write it as 1 minus something. What is 25? 1 minus 0.75. Now can you see it's 75% decay? All right. Now back to this problem. Right here. Careful. What's the decay rate? 25%. Because you could write it as a 1 minus 25. 1 minus 0.25. Okay. Moving on. This is just reminding you that the common ratio is different than the percent increase or decrease. Let me show you. I start with 25. And I'm going to times it by 0.9. Danger. This is difficult kind. Don't use 0.9. Right away change that. And put in what instead? 1 minus 0.1. Now, I'll ask you, what is the decay rate? 10% decay. What is the common ratio? Be careful. 0.9 was the common ratio. That is the number that you would multiply by each time. Like, so let's say I had a 10, and then I multiply by that 0.9, I get 9, because that's 90% of 10, right? And then dot, dot, dot. That's the beginning of my list of terms. Why is it going down? Because I'm multiplying by something less than 1. Does that 0.9 have a purpose? Yeah, it's the what again? Common ratio. But I think you should write it as 1 minus 0.1, because that'll show you the what. What's that called again? Decay rate. This would be a great example to have in your notes. That's the decay rate. 0.9 is the common ratio. All right. That's the biggest moment. That's the biggest thing for today. I only know one person who's ever gotten straight A's in every single class in high school and college. And the one thing they did every night was they checked over their notes for the day from the classes, because it reminded them what the teachers thought was important. Guess what you get tested on? What the teachers think they're important. Okay? So if you want to be that kid, I don't know, maybe you don't care about that. I really didn't care about getting straight A's in high school and college. But there are some advantages to it. You can get into better colleges, you can get better scholarships. And if you really do care about that, that's one of the ways you could do it. It wouldn't take that long. Just take decent notes. Does that mean write down everything the teacher said? Of course not. But figure out what they think is important about that day, like I just said. And then write that down, and then look at that at night. Take you like 3 minutes for each class to review what did they think was kind of important today that they were telling me. And then that's probably what's going to be on the test. And by touching it that one extra time, brain research shows touching it one extra time extended how long you remember something a lot farther if you touch it one more time, because you're telling your brain, hey, this is important. All right. The pink page. You should be able to write everything for this, and it's a good one because it's not just like, oh, I multiplied by 0.2. You have to figure out what you multiply by, the common ratio. And you got to write a formula for it. This is also known as a recursive rule. You know, the u sub 1 equals blah, blah, blah. I do recommend you start with u sub 1 on this. And then it's going to ask you, I see somebody grabbing your calculator. That's good because you're not going to be able to answer question D unless you had a calculator. You can want to borrow one of mine, leave me a shoe or a cell phone or a set of keys to borrow one of mine. And when you're done, I'd like you to check with the kid next to you and see if you got the same thing. Give them about 5 minutes. A student is saying, you know it's growth because it's going up. You are absolutely right. And then how did you decide what to do to figure out that common ratio? So you said 24 minus 20, and that would give you 4, but that wouldn't be the right answer. You know that, right?
Yeah.
So then what do you do now?
So I found that like 4 is 20 is 20%.
4 is 20% of 20, so you knew it was 20% growth. That's cool.
Yeah.
Is there a faster way?
Yeah.
Just give me a quick, dirty way to do this. You know what it is? Maybe I don't know. Because what you did is totally right and has good math instincts and all that, but I just want to show you a shorter way because faster is always better. Not always, really, but it's always good to know a fast way. What's the fast way? Yes, this is 1 plus 0.2, which is a great way to write it so you can see it's 20% growth. But how did you get the 1.2? How do you get the 1.2? Yes? 24 divided by 20. That's all you got to do is this divided by that. It's really fast, and it gets you the same thing. Okay, which was 1.2, which I love that you wrote that as 1 plus 0.2. That's awesome, because later that'll really help to see the percent change. If you wrote 1.2, you're wrong. The percent change is 20%. And when you type it in to Schoology, because this is a Schoology quiz one for today, please don't type in 0.2. Because it'll ask you what's the percent. 0.2 isn't a percent, it's a decimal. 0.2 is 20%. Right there would be good. Thank you. Write a recursive formula for the sequence. I said we should start with u sub 1, so u sub 1 is 20. Could you have started with u sub 0 as 20? Yeah, I just asked you to start with u sub 1 so that we could all grade it the same. U sub n equals u sub n minus 1 times by... This is where I really would like it if you had written 1 plus 0.2. Is 1.2 the same thing? Yes, it is. But this is better. I also know where you're headed. And you know what the more complicated ones look like down the road? Let me show you. This is always the same. But this part morphs into 1 plus the rate divided by 12. And then we're going to like add something on the outside. Okay? Or subtract something on the outside. That's what's going to be in the long run. Do you get why I like having you have it as 1 plus or 1 minus something? Even though 1.2 is correct, it's better to write it as 1 plus 0.2 because I'm getting you ready for this when we start writing like that. And this is a 5% annual rate compounded monthly. You'll get to that later, but I'm trying to show you there's a reason why I think this writing it as a 1 plus 0.2 is really smart. Okay, and then what is the last term less than 100? So basically, you keep growing, and then it almost turns into 100. What's that last term before it turns into 100? U sub 9? Raise your hand if you had u sub 9. You are correct. Awesome. That's assuming you started with u sub 1. Now, if anybody did it as a u sub 0, then that number would be different. But it's still the 9th term. That's why starting with u sub 1 is the safe way to go, because if you want the 9th term, it's u sub 9. Let me make sure you get that difference. let's say I'm going 2, 4, 6, 8, 10. And one kid says, I'm going to start with u sub 1. And the other kid says, I want to start with u sub 0. They're both right. But when I say, which term was 8, they could both find the answer, but they're different. You get what I'm saying? So what if I said, what's the 4th term? Do you get that the person that did it in red would find the 4th term was 8? And the 4th term is 8 no matter what. This person's going to get screwed up because they're going to think that that's the 4th term, but it's not. So if I'm going to ask you what is the 9th term, it's much better to have started with 1 being the first one. Okay? Because what's Mr. Green guy going to think is the 3rd term? He's going to think the 3rd term is 8, but it's actually the 4th term. Is there ever a reason you'd want to start with u sub 0? Actually, there is. Yes. Yes, you have to understand. If there's ever a time to start with u sub 0, it's when you have an experiment. And we do some of those later in this unit. Because at the beginning of an experiment, time is what? Do you think time is 1 at the beginning? No, time is 0. That's why u sub 0 is smart to have in your bag of tricks. But not if they're asking you what the 4th term is. U sub 0 is good when you have an experiment that starts at time 0. And that way, at time 1, you're at u sub 1. You know, after 1 minute, you're at u sub 1. And it all lines up and makes sense again. All right. So, you're done. You know everything you need to know. So, just be careful. Again, when do you start? This is a real-world problem about deer population. Do you think they start at time 1? No, in the real world problems, you start at time 0. All right. So let's get to growth and decay. Let's find the Schoology quiz and we'll start it together. I'm going to pause for a second while we pull that up. Okay, so it looks like this, and we're in growth and decay homework, this Schoology quiz right here. Going to questions. There it is. For each sequence, identify the common ratio, whether the sequence represents growth or decay, the percent change, and whether it's an increase or a decrease. This kind of covers every single thing I just taught you, almost anyway. All right, so looking at this, let's read what it asks you. Do you remember what R stands for? Ratio. So what's the common ratio? Is that the kind you write as 1 plus something? Nope. Common ratio is this divided by this. Somebody in your head can divide 150 divided by 100. It's a decimal. Hint, 1.5. Good. So R is 1.5. Don't write that as a 1 plus 0.5. Not if it's a common ratio. Now, we can write it as a 1 plus 0.5 when you're writing the equation, and it helps you to see the percent change. Is the percent change 1.5? No. It's kind of 0.5, but it's not a percent. 50%. Is that growth or decay, by the way? Growth. So G for that.
Do we actually write the percent sign?
Nope, because no, just don't. They may have put it in there as an alternate answer, but I know they'll accept 50. All right, moving on to increase or decrease. Is it increasing? Well, if it's timesing by something bigger than 1, I hope you know it's increasing. Pretty sure you don't have to use capital I. You could use lowercase I. All right, that's the idea. And it's going to be very similar to that for a whole bunch of questions. Let's move down to where it gets different. All right. There's a matching one in here. All right, this is probably going to be the toughest one here, number 5. Let's look at it together. Suppose the initial height from which a rubber ball drops is, it's supposed to be an is, 100 inches. So basically it drops 100. The rebound heights to the nearest inch are, so when it bounces back up again, this next one was an 80. Think about it. If you drop the ball, it's going to have to bounce lower than it was in the first place. Does this sound like growth or decay then? decay. It's going to get lower and lower and lower and lower and lower. All right. Now, what is the R? I hope you can see that I could divide the 100 by the 80, but they didn't list the 100. This is a common ratio. You could divide that one by that one, or this one by this one. You can divide it by any of those. It's a common ratio, so you can divide any one of them. You always make the second one divided by the first one, though. All right. What's the height of the 10th rebound? Oh, that sounds like I better put it in the calculator. I hope you haven't forgotten how to put them in the calculator. But to be honest, some kids might have since yesterday. If that's the case, please just walk on up to my desk and I'll show you again how to put these into the calculator. In fact, for the video's sake, I'm going to show one on the, and you can ignore me if you remember how to put these in. But I'm going to remind you quick for the kids at home. This would be one where the equation started with u sub 0 equals, and I can tell it would have been 20 because that's where you put it at the end is your starting number. So the beginning and the end are all about the start of your equation. The other one is about the meat of your equation. U sub n equals u sub n minus 1. And then again, this one's adding 4. That's where you put that. Common mistakes. Sometimes people use a capital U right there. Don't do that. It won't work. You also make sure you have a minus 1 there, not a negative 1. That'll screw it up. And by the way, if it ever does, it'll say syntax error, and it'll offer the option to go to. Whenever your calculator offers you the option to go to, I would do it. Because it's offering to go to where the error is. And then it jumps on that screen and shows you, here's the thing I don't get. And a lot of times you're like, oh, that looks like a negative sign, not a minus sign. Or, you know what I mean? Choose the go to option. And it'll bring you to where it's having trouble. All right, so there's just a quick reminder of how to put those in the calculator. This would be a sequence where they're adding 4 each time, starting with a 20, and it was a u sub 0 problem to start with. Could be a u sub 1. More often, that's a 1 right there, because usually we start with u sub 1s. Okay, I think that's enough review of that, and that's all I have for you for today.